Hello everybody, this is Todd Frazee again, and this is the S60-117 CAM tutorial for the secondary piston rod. Now if we look at this part here, we have a lot of similar features to two other components we've already programmed. So hopefully we can steal a little bit of that toolpath and apply it to this one. Okay, so if we were to look at the similar parts, if we go back to the previous two, we've got our secondary piston, which has a slot, and the dimensions on the holes on the slot side are identical. Okay, and so is the slot width. Now if we go back to the 105, it has a tab and it has a loose fitting hole for a 16th pin. So it is very similar and uses the same tools. So we can copy some of the toolpath from both of those jobs to make this part. I will warn you, I've had SolidWorks crash on me a couple times today, and it seems to have to do with copying. It did recover and work fine, but just make sure you're saving after you do everything. Okay. You may not experience that same problem, but just a fair warning there. Okay, so let's go to our model. So here's our model, and we want to copy some information from, let's do the tab side first. Okay, so we've got both parts running here. For the slot side, basically this is all identical. Okay, and that's going to be our operation 2 for the mill. On up 1, we may be able to recycle that as well. So let's go ahead and take the 119 op 1. We're going to right click on it and we're going to copy. Now we're going to go over to our right screen and we're going to go all the way over to the mill tab, and then we're going to do a paste. Okay, and then let's do the same thing for the mill operations. Paste. So we can go ahead and go back to the 119. Let's save that guy and close it. Now let's look at the other operation. We can use the center drill and the drilling from either one of them. So all we need is really the differences, the tab geometry and the reaming from this part. So let's look at this. So we're just taking from the milling tab. So our first operation is cutting the end. We don't need that. We do need slot mill, which is these three operations. And then we need the reaming operation. So we're going to copy those. By right clicking and hitting copy, and then we'll go and we're going to put those in the milling operation as a paste. So we've basically merged these from two different files. Let's go ahead and save the 105 and close it, get it out of memory. Okay, so make sure you're saving. And the first thing I want to do is I want to change these descriptions to the 117. So we're no longer making the 119. And we're going to have to update the setups on both of those. Before we do that, we need to go activate the sketch we use to turn our initial revolve. And so we're going to select that sketch and we're going to make it visible. Tab back over to CAM. And let's set up our lathe job first. We're going to go Edit. Yes, we know we have geometry we need to reconfigure. And we're going to change this to the 117. Looks like I had a typo in my last one with an extra 1. And we're going to go ahead and first make our stock cylindrical to the cylinder of the outside of our part so the orientation is correct. And then we're going to change our spindle orientation. So we're going to use Z-axis and X-axis. So we're going to select the end of the part over here. And we need to make sure our X-axis is in the same plane as this sketch, which it is. If it isn't, you need to select the next box, and you'll need to select the X-axis line for it. Okay, 0 is going to stay on the model front, our stock. And so our radial stock offset's incorrect. We're going from 1/4 inch stock, and we're going to put this in brackets. And we need to subtract our largest diameter, which is 0.197, bracket divided by 2. And that gives us our correct amount of stock. Now, if you copied that profiling from the other file, this number would be correct, but just make sure it's 26 5/10. Okay, and then we're going to leave pretty much everything else at default, provided we've changed all our numbers in here to be the correct part number. Okay, so it's no longer the 119, we're doing the 117. Okay, let's accept that and make sure you save. Now I'm going to go ahead and set up the milling operation too. I suspect that might have been why I crashed last time, so we're going to go ahead and set up the stock for that. So we're doing 117, not the 119, and we're using cylindrical stock. We're going to pick the outside diameter here. And in this case, we're going to use Z-axis, and we're going to pick on, the face is going to be the flat, and we're going to flip our X-axis, and we need to change our origin to the right hand side because that's where all the dimensions radiate from for these features. And so that would be middle side 2, which gives us our orientation. Okay, down on the bottom we need to change this to the 1172 and part number 117. Okay, we're going to accept that. So let's start the regeneration process. Let's start with our lathe ops, and we're going to turn face, and it should auto select the correct face for this. But if it doesn't, and it looks like it doesn't, for some reason it's trying to cut it at the radius. So we need to go to geometry, and we need to delete the line. And actually once we did that and we let it drive it off the model, it corrected itself. So the fact I'd selected line 1 was identified as a different line in this model. So in that case, you can just deselect model. We're going to go to our depths, stock to model ID, that all should stay the same. And then we go to the next tab, that should all stay the same, and the last tab should all stay the same. Okay, so we have our facing operation, which cuts our part. Okay, so now we're going to move on to the second operation. Okay, so we're going to go edit, and on this one we have it auto selecting something, and we're going to have to edit that. We're going to leave we're going to go to the first tab. We're going to leave all this default. Go to the second tab. We're going to delete all the sketch references that are currently in there, and then we're going to put in what we want. So right now it would only cut up. Looks like it would cut actually part of the profile, but then it dies at the slot here. So we're going to select that we're going to cut the radius. We're going to move on to this. You may have another radius here, but I don't in my model. Next step. Okay, so that cuts all of that and includes our chamfer on the lead out. We're going to go to the next tab, and we're going from stock OD, which is fine, and we had it going to a selection point. So I think we want to select fillet. Our radius is a smaller diameter, so we're going to go to that diameter down. Okay, we're going to go to the next tab. We'll leave this at default. Go to the following tab. We'll leave that at default and see what happens. Okay, it did almost what we want from our copy. The only problem is it didn't cut this chamfer and it didn't cut this zone here. That's a specific parameter we had disabled on the previous cut. So let's go and see if we can change that. And it should be under the turning profile tab. And it says do not allow grooving. And we're going to go ahead and allow grooving in both directions. Alright, so then that now allowed us to cut the chamfers. We have our lead off out here. It's actually recutting the face right down to the origin. That's technically okay. I'm not crazy about the angle at which it's coming in at. So let's take a look and see if we can change that. Okay, we had a 0 degree. Let's go to 45 on the lead in and see if that corrects it. Okay, so at least it's leading in at more of an angle, and that cutter should be able to handle that. This part is going to get really thin when it's neck down back in here. Fortunately, it'll be supporting most of the material up until its finished pass. What you need to do is sharpen up this corner. You see there's a substantial fillet, and we have it sharp, and we're going to end up with some possibly some issues there with fit. So we need to go in with a square shaped grooving tool, and so we need to add that to this routine, and we had one. Okay, make sure that your default setup is selected. A single groove routine, and we're going to use from the lathe library, we're going to select the 1mm grooving tool, which is tool number 4. We're going to slow this down to 20 inches a minute. We're going to geometry. We're going to actually select the radius that makes up the groove there. And then that gives us our groove. We want to set this from, it was at middle, we're going to set it at back because we want to offset to the right hand side of the cutter. We want alignment to go to tip. And we're going to go from selection, and we selected this face here as our inside diameter. Okay, we're going to go to the next tab. We're going to leave this at default. And we're going to have full retraction. Okay, so typically I would go in and do this after the fact, after you profiled all this, but because there's so little material supporting it, and now that I think about it, we're going to be taking full material off from the outside diameter of the cutter. So I want to slow this down. This is way too fast. Let's go 10 inches a minute. Okay, so we now have that routine done, but we need to move it up into position to where it's done right after the facing. So we're going to face off the front, we're going to cut a groove, and then we're going to profile. And so we're going to get interrupted cut here where little pieces are going to fly off. And then now we just have the parting operation to do. I'm going to go edit. Okay, so again, it's trying to part some weird spot in the model. That's not where we want it to part. Okay, so we're going to keep all this at default. We're going to go to geometry. We're going to select model components, and we're going to select just that vertical edge there, which puts our cut where it belongs. And we're going to go to the next tab, and we're going to start model OD is fine, and then we're going to go to model ID and go 10 thousandths pass to part this piece off. Okay, there we go. We've now finished the turning portion. This is where we're recycling the milling pieces. Okay, so if we just review, we've got a drill. That's a spot drill. It's going in, making spots. Then we have a deep drilling, and then we have a reaming operation. And those operations all have to be pretty much done after the milling operations. So let's slide all the drilling operations after the contours. Okay. Now we have several slotting contours. We probably should relabel these so we know what they are. Okay, so we're going to call this the spot drill. And then we have a drill bit, and then we have two different reamers. Okay, and we can identify them by the size of the reamer, but I'll label these because we're going to end up copying this information to make the dash 143 and the 145. So it'll be a little bit easier to discern what's what. So let's make sure we've done that. So if I were to edit this routine, the cutter we have here, 59 thousandths 5/10 reamer. So we're going to put 0.059 reamer. And that would make this one the 0.064 reamer. Okay, so this one's for the small holes on each part. This is for the big holes on each part. Okay, and then we spot them with both, and we rough drill them with both. Now let's identify what we got going on here. Okay, so contour 5. We're looking for the parameters that it has a rough depth of the thickness of the cutter with an 8/10 finish pass in Z. That is for the slot side. Okay, we exit out of that, and this makes this tab, and tab, as we had 3 routines to cut the tab. But we've renamed those. Let's make them in order. Now our drawing has, we need to set up our stock. So our drawing has the datum as this end. So that's how we had set up our stock material. So it should be right hand side, cut the length. We don't really have a cylinder that's outside of the box. It's really the model itself. Let's make that one change. Okay, so our stock is actually the model itself.